It runs and drives excellent, the brakes feel great, and it has a ton of power. This thing lights the tires up.
Everyone remembers the Chevrolet 454 big block. They talk about the Ford 429. The Chrysler 440 gets its share of glory too. But what if I told you that one of the most over-engineered, bulletproof V8 engines ever built in America came from a company most people dismissed as an underdog? What if I told you that while the big three were chasing horsepower numbers and magazine covers, a smaller manufacturer in Kenosha, Wisconsin, was building an engine so fundamentally sound, so ahead of its time in durability and design, that it would outlast almost everything else from that era? This is the story of the AMC 401, an engine that deserved to be legendary, but arrived at exactly the wrong moment in history. An engine built with old-school integrity in an industry that was about to change forever. And here's the kicker. Most people have never heard of it. This isn't just a story about cubic inches and horsepower. It's about what happens when you build something too well for a world that's about to stop caring. It's about engineers who refuse to compromise, even when compromise would have been easier and more profitable. It's about an American company that dared to compete with giants and built something that would outlive them all. And that's where the story begins. To understand the AMC 401, you have to understand American Motors Corporation itself. And to understand AMC, you need to step back into the America of the 1950s. This was an era when Detroit was king, when chrome was thick, fins were high, and horsepower was rising every single year. But it was also an era of consolidation, when smaller independent manufacturers were swallowed up or disappearing altogether. Packard was struggling. Studebaker was on borrowed time. Hudson and Nash, two proud independent companies with decades of history, saw the writing on the wall. In 1954, Nash Kelvinator and Hudson Motor Car Company merged to form American Motors Corporation, hoping that together they could survive in an industry increasingly dominated by General Motors, Ford, and Chrysler. The new company set up headquarters in Kenosha, Wisconsin, an industrial city on the shores of Lake Michigan, where Nash had been building cars since 1916. AMC inherited factories, dealer networks, and engineering talent, but they didn't have the deep pockets of the big three. They couldn't afford to compete dollar for dollar on advertising, or to maintain multiple full model lines, or to throw money at racing programs. What they had was ingenuity, determination, and a willingness to think differently. Throughout the late 1950s and early 1960s, AMC focused on what they could do better than the competition: build compact, economical, practical cars. While the big three were building land yachts that got 8 miles per gallon, AMC chairman George Romney pushed the company to produce sensible vehicles for American families who didn't need or want excess. The Rambler became AMC's bread and butter, a line of compact and intermediate cars that were economical, reliable, and perfectly suited to suburban life. In 1959 and 1960, when a recession hit and Americans briefly reconsidered their love affair with giant gas guzzlers, Rambler sales exploded. AMC briefly became the third best-selling automotive brand in America, ahead of Plymouth, an achievement that seemed impossible for an independent manufacturer. George Romney became a household name, preaching the gospel of sensible transportation and attacking what he called gas-guzzling dinosaurs from the big three. For a brief moment, it looked like AMC might actually succeed on their own terms, building smaller, smarter cars for a changing America. But the American market is fickle, and by the mid-1960s, the pendulum was swinging back toward performance and power. The muscle car era exploded onto the American scene almost overnight, and it changed everything. In 1964, Pontiac dropped a big V8 into their mid-sized Tempest and created the GTO, widely considered the first true muscle car. Suddenly, young Americans didn't want sensible compact cars. They wanted cubic inches, horsepower, and quarter-mile times. They wanted tire smoke and exhaust notes that rattled windows. Every manufacturer scrambled to respond. Chevrolet had the Chevelle SS, Ford had the Fairlane GT and the Mustang. Plymouth created the Roadrunner. Dodge built the Charger and Super Bee. Even conservative Oldsmobile got into the game with the 442 and the W machines. Performance was selling cars, and if you didn't have a muscle car in your lineup, you were missing out on the hottest market segment of the decade. AMC found itself in a difficult position. They had built their recent success on economy and practicality, the exact opposite of what the market suddenly wanted. They had inline six-cylinder engines that were reliable and efficient, but hardly exciting. Their largest V8 was the AMC 287, which later grew to the 327, a competent but uninspiring small block that topped out around 270 horsepower in its hottest form. That wasn't going to cut it in an era when Chevrolet was offering 427 cubic inches and Chrysler was building the legendary 426 Hemi. AMC executives faced a choice: stick to their economical roots and watch the performance market pass them by, or develop the hardware needed to compete in the muscle car wars. They chose to fight. In 1966, a team of AMC engineers began developing what would become one of the most underappreciated engine families in American automotive history. The project was led by David Potter, AMC's chief engineer, a man who understood that AMC couldn't simply copy what the big three were doing. They didn't have the budget for that. Instead, they needed to create an engine architecture that was versatile, scalable, and fundamentally sound. An engine that could be manufactured efficiently in their existing facilities, that could be used across multiple vehicle lines, and that would establish AMC as a serious player in the performance market. Potter and his team started with a clean sheet design, but they were constrained by reality. They needed to use existing tooling where possible, keep manufacturing costs reasonable, and create an engine that could meet emissions regulations that everyone knew were coming, even if nobody knew exactly what form they would take. What emerged was a V8 architecture that was brilliant in its simplicity and built like a bank vault. The basic design featured a cast iron block, but not just any cast iron block. While other manufacturers were experimenting with thin wall casting techniques to reduce weight and save material costs, AMC went in the opposite direction. Their block was thick, heavily webbed, and massively reinforced in all the critical areas. The cylinder walls were thicker than necessary. The bulkheads between cylinders were robust. The deck surface was flat and stable. Everything about the basic casting screamed durability and longevity. The architecture incorporated a deep skirt block design, where the block casting extended well below the crankshaft centerline, creating a much more rigid structure than typical shallow skirt designs. This was relatively uncommon in the late 1960s, especially in engines designed for mass production. The deep skirt provided multiple benefits. It stiffened the entire block structure, reduced noise and vibration, and provided better support for the crankshaft underload. The main bearing caps were cast from nodular iron rather than regular gray cast iron, giving them superior strength and resistance to cracking under the extreme stresses of high-performance use. Each main cap was secured with substantial bolts torqued to specifications that left no doubt about AMC's priorities. This was not an engine designed to just barely meet requirements. It was designed to exceed them by a comfortable margin. The crankshaft was forged steel, not the cast iron that many manufacturers use to save money. Forged steel is significantly stronger and more fatigue-resistant, able to handle shock loads and detonation that would crack a cast crankshaft. The crank rode on 5 main bearings, each generously sized for durability and low friction. The bearing surfaces were large enough to spread loads over a wide area, reducing wear and maintaining oil pressure, even under hard use. The connecting rods were also forged steel, with large robust bearings and heavy-duty bolts that could handle far more stress than the stock engine would ever produce. This is the hallmark of true over-engineering, building components strong enough to handle loads they'll never actually see in their intended application. The first engine in this new family was the 290, displacing 290 cubic inches. It was designed as a small V8 that could power intermediate and compact models with decent performance and good fuel economy. The basic architecture was there, but it was just the beginning. AMC quickly realized they could scale this design up. The block had been designed with enough material to allow for larger bores, and the deck height could accommodate longer strokes. In 1967, they introduced the 343 cubic inch version, followed by the 390. The 390 was a strong engine, producing around 315 horsepower in top trim, and it gave AMC products legitimate performance credentials for the first time. But AMC knew they needed more. The muscle car wars were intensifying. Chevrolet was offering the 427. Ford had the 428 Cobra Jet. Chrysler's big blocks were legendary. 390 cubic inches wasn't going to be enough to compete at the top of the performance ladder. So the engineers went back to their design and pushed it as far as the architecture would allow. They increased the bore to 4.165 inches, larger than any previous version. They pushed the stroke out to 3.574 inches, maximizing the displacement they could extract from the basic architecture. When they did the math, the result was 401 cubic inches of displacement. The AMC 401 was born for the 1968 model year, and it immediately became the flagship of the entire AMC engine lineup. But here's what made the 401 fundamentally different from almost every other big block engine of the muscle car era. It wasn't just bored and stroked to chase displacement numbers. Every aspect of the engine was engineered to last. The 401 used the same deep skirt block architecture as its smaller siblings, but with even more material in critical areas. The cylinder walls were exceptionally thick, allowing for multiple rebuilds over the engine's lifetime without sleeving. The deck surface was precisely machined and reinforced to prevent warping from thermal stress. The head bolt bosses were massive, with threads cut deep into thick material that could handle repeated torquing without stripping. The cylinder heads themselves were works of engineering art, at least by 1960s standards. They were cast iron, thick and heavy, with large ports designed for excellent airflow. The intake ports were generously sized and well-shaped, supporting strong volumetric efficiency across the RPM range. The exhaust ports were designed to evacuate spent gases efficiently, reducing back pressure and improving power output. The combustion chambers were wedge-shaped, a proven design that promoted good flame propagation and efficient burning. The valve train was equally robust. The 401 used hydraulic lifters for quiet operation and minimal maintenance, a practical choice for an engine that would spend most of its life in street applications. But the entire valve train system was built to handle far more than stock cam profiles and spring pressures. The lifter bores were precisely sized and located. The push rods were heavy-duty steel. The rocker arms were individually mounted on substantial studs with strong geometry. If an owner wanted to install a more aggressive camshaft later, the basic architecture could handle it without modification. The oiling system deserves special mention because it reveals AMC's engineering philosophy. The 401 featured a full pressure oiling system with generous oil passages throughout the block. The oil pump was gear-driven and substantial, capable of maintaining pressure even at high RPM or during hard acceleration when oil could slosh away from the pickup. The oil filter was full flow, meaning all the oil passed through the filter before reaching critical bearing surfaces. Oil passages to the main and rod bearings were properly sized, neither too small to cause pressure drops nor too large to cause excessive flow and pressure loss. The valve train received adequate oil through push rods that were drilled hollow, delivering lubrication to the rocker arms without requiring external oil lines. Every aspect of the oiling system was designed for longevity and reliability rather than maximum performance. AMC knew that most 401s would spend their lives in street vehicles driven by regular people who might not change their oil as often as they should. The oiling system needed to forgive neglect and abuse while still protecting the engine, and it did. Stories abound of 401 engines that were run low on oil or went too long between changes but survived without damage because the oiling system was simply that robust. The cooling system was equally well engineered. The block featured large water jackets surrounding all cylinders, with generous coolant passages that promoted even temperature distribution. The water pump was substantial and reliable, pushing coolant through the system with authority. The thermostat housing was easily accessible for maintenance. Everything about the cooling system was designed to keep temperatures stable under varying conditions, from stop-and-go traffic to sustained highway cruising or heavy towing. In stock form, the AMC 401 produced between 330 and 340 horsepower, depending on the specific year and application, with torque figures typically around 430 foot-pounds. Now, let's be honest about those numbers. They weren't class-leading. The Chrysler 440 produced 375 horsepower in standard form, and the legendary 426 Hemi made 425 horsepower. Chevrolet's 454 Big Block could be had with 450 horsepower. Ford's 429 Super Cobra Jet made 370 horsepower, and that was probably underrated. The AMC 401 simply didn't have the biggest numbers, and in the muscle car era, numbers were everything. Magazine road tests, drag strip time slips, and bragging rights at the local cruise night all came down to horsepower figures. But AMC wasn't trying to win magazine shootouts or set drag strip records. They were building an engine that would survive decades of real-world use, and that required a different set of priorities. The relatively conservative power output was intentional. AMC used compression ratios that were reasonable rather than extreme, typically around 9.5 to 1 or 10 to 1 depending on the year. This meant the engine could run reliably on the pump gas of the era without detonation problems, and it would be more tolerant when emissions regulations forced fuel quality to decline in the mid-70s. The camshaft profiles were mild, prioritizing low-end torque and smooth idle over peak horsepower. The intake and exhaust systems were designed for broad power delivery rather than peaky performance. Everything about the engine's tuning was conservative and designed for durability. The golden era of the AMC 401 began in 1968 and ran through the early 1970s, a brief shining moment when AMC competed directly with the Big Three in the muscle car market. During these years, the 401 found its way into some of the most memorable machines AMC ever produced, and it proved itself in ways that went far beyond magazine racing. The AMX was perhaps the 401's most famous application. Introduced in 1968, the AMX was AMC's answer to the Chevrolet Corvette, a bold statement from a company not known for boldness. It was a compact two-seat sports car with a short wheelbase of just 97 inches, aggressive styling with a long hood and fastback roofline, and genuine performance credentials. With the 401 engine under the hood, the AMX became a legitimate muscle car that could run with anything short of the most radical factory offerings. Road tests of the day showed the AMX running low 14-second quarter miles at speeds around 95 miles per hour, respectable numbers that put it in the same ballpark as Mustang GTS and Camaro SS models. It wasn't the fastest car on the street, but it had character, presence, and that big AMC V8 delivered power with a deep, authoritative growl that commanded respect at every stoplight. The AMX turned heads everywhere it went, partly because of its unusual styling, and partly because people couldn't quite believe that AMC, the company known for sensible ramblers, had built something this aggressive. The Javelin, AMC's pony car competitor, introduced alongside the AMX, also received the 401 as its top engine option. The Javelin was AMC's answer to the Ford Mustang, Chevrolet Camaro, and Plymouth Barracuda, entering a crowded market where it would have to fight for every sale. The base Javelins were powered by six-cylinder, or small V8 engines, and were pleasant but unremarkable. But in top-trim SST and AMX versions equipped with the 401 engine, the Javelin became something special. It offered genuine tire-smoking acceleration, a soundtrack that rivaled anything from the Big Three, and handling that was surprisingly good for an American pony car of the era. AMC even campaigned Javelins in Trans Am racing, the premier road racing series for pony cars in North America. They brought in Mark Donohue, one of the best drivers of the era, to pilot their cars. While AMC couldn't match the factory muscle and unlimited budgets of Chevrolet and Ford in Trans Am, they earned genuine respect for their engineering prowess and never-quit determination. The racing effort proved that the basic AMC V8 architecture could handle competition use, that it could be built to survive sustained high RPM operation, extreme loads, and the kind of abuse that destroys lesser engines. Modified 401 engines and Trans Am trim produced well over 400 horsepower, while maintaining reliability through endurance races, a testament to the strength of the basic design. But the 401 wasn't just for sports cars and pony cars. AMC installed it throughout their lineup, and in some ways, these more mundane applications better demonstrated the engine's real virtues. The Rebel, AMC's mid-size sedan, could be ordered with the 401 engine. In this application, the massive torque and smooth power delivery made the Rebel a genuine sleeper, a family sedan that could surprise unsuspecting muscle car drivers at stoplights. The big engine gave the Rebel effortless highway passing power and the ability to haul a trailer or boat without complaint. Later, when the Rebel was renamed the Matador for 1971, the 401 carried over, powering AMC's largest passenger cars with authority and refinement. These weren't glamorous applications, but they were important. They showed that the 401 was versatile, that it could be refined and quiet when needed but still deliver strong performance when the throttle opened. Family men bought Matadors with 401 engines and drove them for years, racking up miles towing campers, hauling families cross-country, and commuting to work. The engines just kept running, asking for nothing more than regular oil changes and basic maintenance. One of the most significant and enduring applications came after AMC purchased the Jeep brand from Kaiser in 1970. This was a transformative acquisition for AMC, giving them ownership of an iconic American brand with tremendous potential. Jeep brought established model lines, including the CJ, the full-size Wagoneer, the pickup truck J-Series, and the newly introduced Cherokee. Kaiser had been using various engines and Jeep products, including Buick Vates, purchased from General Motors, but AMC immediately began transitioning Jeep vehicles to their own power plants. The 401 found its way into the Jeep J-Series trucks, the full-size Wagoneer, and later into the Cherokee Chief. the upscale version of the Cherokee that competed with Chevrolet Blazers and Ford Broncos. In these big, heavy four-wheel drive vehicles, the 401's torque and durability made perfect sense. These were trucks designed for serious work and serious recreation. They needed to haul families and gear over mountain passes, tow boats and campers across the country, and power through mud, snow, and rocks without complaint. The 401 delivered all of that with remarkable reliability. Jeep owners quickly discovered that the AMC 401 was nearly indestructible. They loaded these trucks to maximum capacity and beyond. They drove them through conditions that would destroy lesser vehicles. They worked them hard every single day. And the 401s just kept running. Oil leaks were common because it was the 1970s and everything leaked oil. But catastrophic failures were rare. Engines that received even basic maintenance regularly reached 200,000 miles without needing major overhauls. Stories circulated among Jeep enthusiasts of 401-equipped trucks reaching 300,000 miles, 400,000 miles, even 500,000 miles on original engines that had never been torn down. These weren't garage queens or pampered collectibles. These were working trucks that earned their keep every day. The durability came from all those design decisions that seemed like overkill when the engine was new. The thick block casting could handle decades of thermal cycling without cracking. The deep skirt design kept the crankshaft stable under the shock loads of four-wheel drive use, when wheels would hit obstacles and send impacts straight through the drivetrain. The forged internals could handle detonation from bad fuel and abuse from drivers who didn't know or care about proper maintenance. The generous bearing surfaces meant that even when oil got dirty or change intervals stretched too long, the bearings survived because loads were spread over such large areas. The conservative tuning meant the engine never operated at the ragged edge where failures happen. AMC had built an engine with massive safety margins, built into every system, and in harsh real-world use, those margins paid dividends year after year, decade after decade. Farmers bought J-Series trucks with 401 engines and used them to haul feed and equipment. Construction contractors bought Wagoneers and used them as work trucks. Families bought Cherokee Chiefs and used them to explore America, driving unpaved forest roads and trails that would test any vehicle. In every application, the 401 proved itself. It became the engine you wanted if you actually planned to use your Jeep for something more than mall parking lots and pavement. What made the 401 so extraordinarily durable in real-world use goes beyond just strong parts. It was a systems-level approach to engineering that considered how components work together under stress. The thermal management was exemplary. The thick block casting acted as a giant heat sink, absorbing thermal energy and dissipating it gradually rather than creating hotspots that cause warping and cracking. The large water jackets and substantial coolant passages promoted even temperature distribution across all cylinders. The cylinder heads, though heavy, managed heat well because of their mass and the quality of the casting. This meant the engine could handle sustained high loads, like climbing mountain passes with a heavy trailer in summer heat, without overheating or developing problems. The mechanical robustness went beyond just using strong materials. The deep skirt block design reduced vibration and kept the crankshaft stable under load, which reduced wear on all rotating components. The main bearing caps were precisely machined and fitted, creating a stable foundation for the rotating assembly. The connecting rods were properly sized, with good length-to-stroke ratios, reducing side loads on pistons and cylinders. Every aspect of the rotating assembly was designed to work in harmony, reducing stress and wear across the entire system. The oiling system maintained consistent pressure across the RPM range and delivered adequate lubrication to every bearing surface, even under extreme angles when off-roading or during sustained high-G cornering. The engine's conservative tuning played a crucial role in its longevity. By keeping compression ratios reasonable and using mild cam timing, AMC ensured the engine ran smoothly and reliably on whatever fuel quality was available. This became increasingly important in the mid-70s when fuel quality declined and octane ratings dropped due to the removal of lead and other additives. Engines tuned for maximum power with high compression and aggressive timing suffered detonation and damage on the low-quality fuel of the late 70s. The 401 just kept running. But nothing in Detroit lasts forever, and by the early 1970s, the world was changing in ways that would doom engines like the 401 and the entire philosophy of automotive engineering it represented. The first blow came from emissions regulations. which arrived like a thunderstorm that everyone could see coming but nobody was truly prepared for. The Clean Air Act of 1970 established national air quality standards and gave the newly formed Environmental Protection Agency the authority to regulate vehicle emissions. Suddenly, manufacturers were required to drastically reduce hydrocarbons, carbon monoxide, and oxides of nitrogen coming from exhaust pipes. And they had to do it quickly. The technology to reduce emissions efficiently didn't exist yet. Catalytic converters were in their infancy. Electronic fuel injection was still experimental for automotive use. Engine management computers were primitive. The solution in the early 1970s was to strangle engines with crude emissions equipment that reduced power and efficiency simultaneously. Air pumps forced fresh air into exhaust manifolds to burn unburned hydrocarbons. Exhaust gas recirculation systems diverted exhaust back into the intake to lower combustion temperatures and reduce oxides of nitrogen. Restrictive catalytic converters were fitted to exhaust systems. Compression ratios were slashed to allow engines to run on unleaded fuel as leaded gasoline was phased out. The AMC 401, like all big engines of the era, suffered tremendously under these new regulations. By 1971, compression ratios were dropping from 9.5 to 1 down to 8.5 to 1 or lower. Restrictive exhaust systems strangled power output. Retarded ignition timing reduced efficiency and hurt throttle response. Power outputs began to plummet. An engine that had produced 330 gross horsepower in 1970 was down to around 255 net horsepower. By 1972, using the new SAE net measurement standard that more accurately reflected real-world output. The engine was still fundamentally strong and durable, with all the robust internals and overbuilt architecture intact, but it was being suffocated by regulations it wasn't designed to meet. The power loss was frustrating for enthusiasts, but even worse, fuel economy didn't improve significantly despite the power reduction. The primitive emissions equipment actually hurt efficiency in many cases. Then came the oil crisis, and everything changed overnight. In October of 1973, in response to American support for Israel during the Yom Kippur War, the Organization of Arab Petroleum Exporting Countries, or OPEC, imposed an oil embargo against the United States and other nations. Oil prices quadrupled almost overnight. Gasoline prices more than doubled, then tripled in some areas. Long lines formed at gas stations across America. Rationing became common. The evening news showed footage of frustrated Americans waiting hours just to fill their tanks. The psychological impact was profound. Americans had never questioned the availability of cheap, abundant gasoline. Suddenly, that assumption was shattered. The oil crisis didn't just make gas expensive, it made Americans fundamentally reconsider what they wanted from their vehicles. Overnight, Woody wanted a car with a 401 cubic inch V8 engine. The muscle car era ended as abruptly as it had begun. Young buyers who had been shopping for Camaros and Challengers started looking at Datsuns and Toyotas. Families shopping for full-size sedans considered compacts. Instead, fuel economy became the only metric that mattered, and big blocks were the enemy. Sales of large, powerful vehicles collapsed, while imports and small domestic models saw demand surge beyond supply. For AMC, already struggling financially and barely profitable even in good years, the oil crisis was devastating. They had finally developed competitive performance engines and vehicles, finally built the hardware to compete with the big three in the muscle car market. And suddenly that entire market evaporated. The 401, with its heavy forged components and overbuilt architecture, was expensive to manufacture. Each engine cost AMC significantly more to build than a comparable big block cost General Motors or Ford, because AMC had smaller production volumes and couldn't achieve the same economies of scale. When the engine was selling well in performance cars and premium Jeeps, the cost was justified. But in the post-oil crisis world of 1974 and beyond, when consumers actively avoided large engines, the 401 became a financial liability. AMC couldn't afford to keep manufacturing and developing large displacement engines that few people wanted to buy. The company faced difficult choices about where to invest their limited resources. And increasingly, those resources were directed towards smaller, more fuel-efficient engines and vehicles. By 1974, AMC began phasing out the 401 in passenger cars. The AMX had already been discontinued after 1970, a victim of declining muscle car sales. The Javelin struggled on through 1974 before it too was discontinued. The Matador and Ambassador continued to offer the 401 as an option through the mid-70s, but take rates were low and getting lower every year. Only in the Jeep truck lineup, did the 401 remain relevant, where its torque and durability still made sense for heavy-duty work and serious off-road use. The J-Series pickups and full-size Wagoneers and Cherokee Chiefs continue to offer the 401 as the top engine option through 1978, serving buyers who needed maximum capability and were willing to pay the fuel economy penalty. But even in Jeep applications, the writing was on the wall. The future belonged to smaller engines, 6 cylinders instead of V8s, and eventually to fuel injection and computerized controls that could squeeze efficiency from every drop of gasoline. AMC's financial troubles deepened throughout the late 1970s as the company struggled to compete in a changing market without the resources to develop new products quickly. Their passenger car lineup consisted mostly of aging designs that couldn't compete with newer offerings from the Big Three and increasingly popular imports. The Pacer, AMC's attempt at an innovative small car, was a sales disappointment. The Gremlin and Hornet were competitive, but not profitable enough to support the entire company. AMC needed capital for new product development, and they found it in an unlikely place. In 1979, AMC formed a partnership with Renault, the French automaker, which purchased a significant ownership stake in the struggling American company. The Renault partnership brought desperately needed cash, but also pushed AMC towards smaller, more fuel-efficient vehicles aligned with European sensibilities. There was no place in this new direction for engines like the 401. When the last AMC 401 rolled off the assembly line in 1978, installed in one of the final Jeep trucks to receive it, the end came quietly, without ceremony or acknowledgement. It marked the end of an era not just for AMC, but for an entire philosophy of engine building, a philosophy that had defined American automotive engineering for decades. The 401 represented the old way, where durability and longevity were paramount considerations in design, where components were forged instead of cast to save money, where block walls were thick instead of thin, where an engine was deliberately overbuilt to outlast the vehicle it powered and provided a safety margin for abuse and neglect. That approach was too expensive for the modern world that emerged in the 1980s. Manufacturers learned through market research and financial analysis that engines didn't need to last 300,000 miles if the average vehicle would be scrapped or recycled at 150,000 miles anyway. They learned that buyers would accept more frequent maintenance intervals and shorter component lifespans if the initial purchase price was lower. They discovered that with sophisticated marketing and planned obsolescence, they could actually benefit from products that wore out and needed replacement. The 401 was a dinosaur in this new economic reality, beautifully engineered but commercially extinct. AMC itself wouldn't survive much longer in its independent form. The Renault partnership led to increasingly badge-engineered products and declining market share. In 1987, facing bankruptcy, AMC was purchased by Chrysler Corporation in a deal that was really about acquiring the Jeep brand. Chrysler wanted Jeep's reputation and dealer network and saw tremendous potential in the brand. The rest of AMC, its passenger car lines and remaining infrastructure, was essentially dismantled or absorbed. The Kenosha assembly plant where AMC 401s had been built was closed in 1988, ending more than 70 years of automobile manufacturing in that Wisconsin city. The AMC brand disappeared from American showrooms, reduced to a footnote in automotive history books that focused on the Big Three. For those who had worked at AMC, who had engineered and built products they believed in despite limited resources and constant struggles, the end was bittersweet. They had competed against giants and created some genuinely excellent products, but the market had not rewarded their efforts sufficiently to ensure survival. But here's the remarkable thing about engines that are built too well. They don't just disappear when production ends. They persist. They survive. They outlast the companies that made them and the era that shaped them. Today, more than 45 years after the last AMC 401 was manufactured, these engines are experiencing a genuine renaissance among enthusiasts, restorers, hot rodders, and collectors who understand what they represent. The 401 has become a cult favorite in the classic AMC community, prized for exactly the qualities that made it commercially unsuccessful in its own time. Its extraordinary durability means that good running 401s are still available, pulled from Jeep trucks that have been parked in barns and yards across America. Its overbuilt architecture means it can handle significant power increases with minimal internal modifications, making it an attractive basis for high-performance builds. Enthusiasts have discovered that with modern aftermarket components, including aluminum heads, electronic fuel injection, and improved induction systems, an AMC 401 can reliably produce 500 horsepower or more, while maintaining the legendary durability that made it special. That deep skirt block and forged rotating assembly that seemed like unnecessary overkill in 1971 now provides the perfect foundation for a modern Restomod build that combines vintage character with contemporary performance and reliability. The AMC enthusiast community, though smaller than groups devoted to Chevrolet, Ford, or Mopar products, is passionate and dedicated. They have kept detailed records, manufacturing specifications, and comprehensive rebuild guides for the 401 and other AMC engines. Online forums and social media groups are filled with detailed build threads documenting restorations and modifications, with members sharing knowledge about parts sourcing, machining specifications, and tuning strategies. Specialty suppliers have emerged to serve this niche market, offering performance parts specifically designed for AMC engines. You can buy modern aluminum cylinder heads for the 401 that flow significantly better than the original cast iron units while reducing weight. Electronic fuel injection systems designed specifically for AMC V8s are available, bringing modern fuel delivery and management to these vintage engines. High-performance camshafts, valve train components, and induction systems allow builders to extract far more power than AMC ever did while maintaining reliability. Some of the most impressive builds combine the 401's industrial strength with cutting-edge technology, creating engines that produce modern power levels while retaining the character and soul of vintage American V8s. These engines are being installed.